this lecture, let us discuss about towers of Hanoi problem. So it's a mathematical problem which is composed of three towers and numerous rings arranged in increasing order of their diameters. So the number of towers here, it is constant for this problem, whereas the player can vary the number of rings he wants to use. So before going into the problem, first we need to understand few rules here. So in order to shift the entire stack of discs from one rod to another rod. So here in the picture, you can see these are the rods. So in order to shift the stack of discs from one rod to another rod, we need to follow these three rules. So only one disc can be moved at a time. So you can move only one disc, and only the uppermost disc from one stack can be moved to another stack. So here we are having green color, so which is the uppermost disc. So you can move that from, so you can move only this green color disk from one stack to another stack. It can be either two or three. And larger disk they cannot be placed on top of small disk. Say suppose if you move this to stack 2, then you can't place this blue color one on top of green color one. Okay. So larger disks they cannot be placed on top of smaller disks. So now this is the initial state and the goal state is this one. So here you need to move all the disks from rod 1 to rod 3 and arrangement should be like this. Now let us see how to solve this problem. Here in step 1, the smaller green disk, the uppermost disk on the stack, it is shifted to rod 3 from rod 1. So after performing this operation, representation will be like this. Okay. Next, the uppermost disk on rod 1. So what is the uppermost disk on rod 1? That is blue color disk, right? So this should be shifted to rod 2. So after doing that, representation is like this. And the smallest disk. So what is the smallest disk here? That is green color one, which is placed on rod 3. Now you need to shift this back onto top of rod 2, so that this rod will be empty, so that you can push or you can shift the red color disk to top of rod 3 if this is empty. So for that we are moving this green color or the smallest disk back onto top of rod 2. So after doing that, this is a notation. Now this is empty, right? So you can directly shift this red colored or the largest red disk. It shifted from rod 1 to its destination rod 3. So this is a notation after doing this task. And now the two disks on rod 2. So you can see there are two disks on rod 2. They should be shifted to its destination rod on top of red disk. So first the smallest green disk on top of blue rod is shifted to rod 1 because you can't place largest disk on top of smallest disk. So if you place this green color one on top of this, then you can't place this blue color on green color disk. So first the smallest green disk on top of blue colored rod should be shifted to rod 1. And after this is the notation after performing that. Next, you need to move or the blue colored disk is permitted to be shifted towards destination rod 3. That will be stacked on the top of red disk. So this is the notation now. And what is our target? So our goal is to move this green color disk on top of blue color, so that all the three disks, they should be in rod 3. They should be shifted towards destination rod. So finally the smallest green colored the green colored rod, it is also, sorry. Yeah. Finally the smallest green colored disk is also shifted to rod 3. So which would now be the uppermost rod on the stack. So you can see this is the uppermost rod on the stack, uppermost disc on the stack. So this is our goal.